Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When an unsaturated carboxylic acid is treated with I2 in the presence of NiHCO3, a mild base that deprotonates the carboxylic acid to form the carboxylate anion, an iodolactonization reaction occurs. Moving on to the next step. Identify the substrate. 4-pentanoic acid is CH2 is equal to CH, CH2, CH2, Cu. The double bond is between C4 and C5I, a terminal alkene, with the carboxylic acid at C1. Moving on to the next step. NiHCO3 deprotonates the carboxylic acid to generate the carboxylate anion, Cu, which acts as an internal nucleophile. And for the final step, I2 acts as an electrophile and activates the double bond by forming an iodonium ion intermediate across the C4 is equal to C5 double bond. The carboxylate oxygen performs intramolecular nucleophilic attack on the more substituted or accessible carbon of the iodonium ion, C4, which is the internal carbon bearing the chain, via an anti-addition, following Baldwin's rules. A 5-membered ring transition state, 5-exotate, is favored over a 6-membered ring. The 5-exotate cyclization places the oxygen from the carboxylate at C4 forming a 5-membered lactone ring, gamma-lactone is equal to dihydron, 2-1, with the iodine ending up on the exocyclic CH2 group, C5 the terminal carbon, giving 5-iodomethyl, dihydron, 2-1. A 4,5-deodopentanoic acid. This would result from simple addition of I2 to the double bond without lactonization, incorrect. B 5-iodomethyl, dihydron, 2-1. This is the product of 5-exotate iodolactonization forming a 5-membered lactone with CH2I substituent, correct. C 5-iodo, tetrahydropyrin, 2-1. This would require a 6-membered lactone via 6-endotate cyclization, which is disfavored by Baldwin's rules compared to 5-exotate, incorrect. D 4-pentenyl iodide. This implies simple acid iodide formation, not relevant here, incorrect. Therefore, the correct answer is B. Therefore, the correct answer is option B.